vai direto.
Eu acho, lembrando. O áudio do professor lá tava perfeito.
Vai, por favor, lá por Meets e abre no áudio. Permite todo mundo. Uh, hello, Domi. Can you hear me?
Hello, Yuri. How are you?
I'm fine, thank you. Sorry for the delay. Here we had a storm yesterday, and our internet connection is really very poor. I think now we are online again, and we activated the transmission. So if you can please share your screen, so we can start the presentation.
Okay. Okay.
Sorry for it.
Thank you very much.
Thank you.
Não, eu mandei. Professor Gabriel, está com internet, só tem só o YouTube. Eu acho que o YouTube voltou.
Volta, por favor, lá, falar com
Live, tá live.
Tu compartilhou a tela, Dumi?
Dá não.
Ok.
Okay, I will share
Thank you.
right
Só reconstruir agora esse lugar. Se não cair a internet, não vai ficar. Ficou bacana.
now. So, you see my screen?
Yes, we are seeing.
Oh,
Just,
okay. Thank you. So, let's start.
yeah, just a second. I will present to you and
Thank you very much for this opportunity to present some cases.
just a second, Domi. Just a second. Sorry.
Okay.
Seu errado. Não vai ligar. Hello everyone. Now we are back. So let's continue. Now we will go to the presentation from Aldomir from Unicoba. Unicoba is a Brazilian company battery. So Aldomir, thank you for accepting to participate of this event. And okay, now we can start. Thank you.
Okay, thank you very much for this opportunity to present our cases. My name is Ramir. I'm in charge of sales and application engineer department of Unicoba. I will explain a little bit about our company. We are a Brazilian company, almost 50 years. We are based at Manaus. We have a factory in Manaus of lithium batteries, and also in Extrema, the southwest of Brazil. Okay, we have around 1,000 employees. We have two main divisions. One of the professional lighting, based in the public concessions using LID illumination, and another of energy storage that I will explain our products. Okay. So, like I said, we are the first Brazilian stationary lithium batteries manufacturer. Okay, we already designed a lot of projects in the region of Amazon jungle, also in the southwest for telecoms proposal. I will explain later. Okay, and the idea here is to talk about how and where storage contributes to the energy transition, and it includes the second life batteries. Okay, so for in our projects use brand new batteries of lithium. Okay, but the idea in the near future is to use for stationary projects use second life batteries from the electrical vehicle. So many research are being performed in this area. So the idea is to explain the agenda of Brazil and also of the world. Uh, we are directly connecting on 4 SGA of ONU, okay, and also we are signatory of the ONU Pact of the Sustainability of the World. So our purpose is the energy 4D, and nowadays we performed the main projects are the SIGFI and MIGD solution for 7 isolated locations, né, totally off grid using lithium batteries. Né. This kind of project use solar panels, a charge controller, inverter, and lithium batteries, né, for use on one residence or a small village or a small neighborhood. Okay. And also you can mix the source of the energy using a renewable energy or grid or diesel generator, the batteries, EMS, energy management system, né, to control all these different sources and use directed into the load to the better way of the energy using the mixed sources. Like I said, also in the telecom energy solution, you can use off-grid solutions to the telecom proposals like the tower telecommunication centers in isolated areas. Also in the Amazon region, I think you have more or less 5 to 10 plants based in this solution for telecom using lithium charge controllers and solar panels. And this is the first case I would like to present. Okay, we are working with the main constructors of the infrastructure, telecom infrastructure services, such EHS, WINIT, Highline, for the TEAM project. Okay, the idea of this project is deliver the 4G network to remote regions, totally off grid. So we build all the solution using solar panels, the lithium batteries. These batteries are 48 VCC batteries with 100 ampere hour of capacity. It's around 5 kilowatt hour of energy capacity. Okay. Also use a charger for this battery using the DC power of the solar panels to charge these batteries, and the batteries feed the load for this all the equipment of telecom equipment here. This kind of solutions provides more or less about 98% of reliable energy during the year, with a missing energy around 2 or 3%. It depends of the place that this project are installed. But it's a very reliable solution using lithium batteries. At this case, these batteries, we use the depth of discharge, DOD, around 90%. Okay, the number of cycles using this depth of discharge, it's around 6,000 cycles. So we are talking about, if you use 1 cycle per day, it's around 10 to 12 years of warranty and the cycle of life of this project, okay? And the state of health, of these batteries at the end of this period, it's around 80%. This is another solution. So this solution, it's for residential purpose, okay, and one grid. The idea is to
to do the load shifting and the backup purpose for a residential purpose. This route, it's based in São Paulo, near of the headquarters of Unicobo. Okay, this house contains a grid, but it is a poor quality of energy. So this kind of solution provides a better quality of energy, and also and the time between 5 to 8 p.m. you can inject the energy from the batteries that you charged in a better tariff of the day. Also, you can use the solar panels to recharge this battery, and you can guarantee a reliable backup for this house. All this kind of project, like I said, in the future, you can use the second life batteries. Eh? The, the, the main challenge of this is to build, to use a BMS that could control and stabilize the cells from the batteries of the electrical vehicles. It's a little bit different of this kind of stationary batteries, but it's possible. So we are talking about in a second or a third life batteries, all the cycle of the recycle of the lithium battery lives. That's very important to us, né? And this kind of project are in our this kind of project is in our road trip studies. This is a SIGF. We implemented around 900 at the Rondônia state. Was our first project that we did with the Amazonas Energia. This is a SIGF using 4 solar panels and 2 batteries of 50 ampere hour and 48 voltage. Okay, this is a SIGF 45 kilowatt hour per day. That's very suitable to small houses for cooling, lighting, and communication. And you can see at this picture, the challenge here is to implement the solar panels in the float houses, and all the boxes that contains the battery and the electronic devices must protect it from the flood. This is our R&D project based in Santa Helena do Inglês, very near of Manaus. This is a hybrid plant that use diesel generator, solar panels, and batteries. We are talking about more or less 54 batteries with a total capacity 260 kilowatt hours of capacity. You are using 48 VCC batteries connected in parallel, okay? And the solar panels, it's around 132 solar panels with 53 kilowatt of power generation. And this project we made this project with a partnership with FAS, Fundação Amazônia Sustentável, and this project changed all the life of the people that live in Santa Helena do Inglês. It's very grateful to see how energy can change the life of this person. He can improve the quality of life. This is a picture, the soccer mat that we made with the local population of Santa Helena. This match dured all night long. It's around 6 p.m. to 6 a.m. using the backup of the batteries. it was great, this project. Okay, and nowadays you can provide this kind of solution using the lithium batteries and hybrid inverters. It's a very reliable kind of solution. Okay, and you can mix, like we did here, another source of energy, such as the diesel generator, for example. This is another project called telehealth. We did at the during the COVID-19. It's a mix using the energy and telecommunication purposes that provides online transmission with medicine, with doctors, to attend all this population around the Amazon region, about 72 riverside communities. It prevented the broadcast of the COVID-19 in this region, and you also used the lithium batteries and radio and telecommunication equipment. Okay. So this is the main project that we did here. I would like to increase that. We are starting also the manufacturing of the batteries for motorcycles, the electrical vehicle of motorcycles. We are starting right now. It's around 5 months ago. So we are open to discuss with the university and all the technology institute how can you can improve the use of the second life batteries in this kind of project. We are open to discuss also to use these batteries at our factory. Thank you very much. We are open. I don't know if you can discuss the questions right now or later, Yuri, but that's the idea of my presentation. Thank you very much.
Thank you, Dominic. Very interesting presentation. We will do a session of question and answers after the next presentation. If you can please stay on the Google Meet,
okay,
so we can discuss more in some minutes, okay?
Okay. I'll be here.
So, Carlos, can you hear me, Carlos Rufino?
Yeah, I can hear you.
So now it's the presentation of Carlos Rufino. He is also from Eurostats. If you can please share your screen, and so you can start your presentation when you want after sharing your screen. Thank you.
Thank you, Professor Yuri. Just one moment, because I am using multiple monitors here. Just let me check. Yes. You see my screen now?
Yes.
Okay. Hello, everyone. It's a pleasure to be here, to join into this workshop, and I am quite happy to present the results or the recent results which we have developed or which we have got here. Then let's start. So my name is Carlos Antônio Rufino Jr. I am a research assistant at the Technische Hochschule Ingolstadt. The Technische Hochschule Ingolstadt is a research center, and here we are able to perform some better tests from cell level to pack level. That means that if you have interest in testing your battery, for instance, second life batteries, we are able to test the batteries here. And yeah, we have a very strong capability to perform some tests, such as safety tests, performance test, and characterization test. Uh, Here I work together with Professor Schwager, who is the head of this institute. So we have different directions, I would say. We are able to study about abuse, or that means that we are able to perform some abuse tests, and we are able to investigate some safety concepts. Uh, we are also able to perform some destructive tests from cell to vehicle level. Study about firefighting, um, and today on this lecture, I will have focus on this. How can I say, on this research line? For instance, modeling and simulation, right? So then we have plenty of research projects such as Marble, Cobra, Sapphire, uh, that that means that we have a very uh, we have a plenty of European projects and industrial projects as well, such as the Prima and another ones. Here there are some pictures from our facilities. We have a cell lab, which in this lab we are able to perform some tests at cell level, and we can perform some tests indoor. But if you need to perform some abuse tests, we can perform tests outdoor as well. And we have a high voltage laboratory with some climate chambers. For instance, we have some mechanical press, which we can press. You can evaluate how the cells performs in such scenarios, and we can also investigate some nail penetration, and we can investigate short circuit, and we also have some high voltage tester from 50 to 800 volts. The current per channel is 500 amps, and we have more than one channel. And we have module tester and cell tester as well. And we can perform some tests using our climate chambers. There are more climate chambers than that, and the bigger ones as well. But here we are able to investigate scenarios from minus 42 to plus 108 Celsius degrees. So then, now I can start my presentation after the short presentation from the research center. What we have seen in our newspapers is that the manufacturers or the vehicle manufacturers has been publishing that they will stop making combustion engine cars by 2035 in Europe and around the world. So that means that we need to prepare ourselves for this future. And the future is being built today. So we are developing the technology which will be applied on the future, right? So then the battery is a reality, but it's not just a reality in electrical vehicles, but it's a reality in stationary application, and for instance, in forklift, in boats, and so on. And we can see that the market from batteries has been increasing. So the battery demand has been increasing over years. We can see that we have an exponential growing in this market. and the second life battery is increasing as well, and we need to be able to to access this market. What is the battery, or what does mean second life batteries? The batteries age at different rates. That means that if we have different operational conditions, we have different scenarios, and we have different aging mechanisms inside the batteries. And the batteries, after 80% of nominal capacity, we expected that the battery has no enough range, safety, charging time, cost, and residual values. And then, we have the capacity decreases, and we cannot keep the batteries in the car because it's not safety. It's not safe, and the range is not good enough. But the lithium-ion batteries are complex systems, and we have different aging mechanisms, and we need to understand the age mechanism in order to model the battery and in order to know what is the right moment to take out the battery from the vehicle and put the battery in another application. And we need to model the battery in order to know how long the battery lasts in a vehicle, and and we need to control the battery in order to keep it safe. For instance, we expect that the second life batteries will have a very strong aging mechanism and gas evolution inside the battery. So I would say that the second life batteries are safe, yes, but we need to control the battery, right? And then on my next lecture, I will show some results from our control system, but in this lecture, I would like to show the battery modeling and the battery models that we have developed here. We have two different aging modes. We have calendar aging, and